Just waiting for some people to show up here. Right now we have a grand total of 0 people. Alright, we got people coming in. So we're going to get started with this live broadcast here in a minute. You'll see camera moving around as we try to show you some images of what's going on. While we're getting set up, feel free to go ahead and start putting some questions in the hopper there, and we'll work on getting those answered as we go through this. So today, you can slide into the queue here. This is one Jason Puma, lead meteorologist at the National Weather Service here in Indianapolis. Say hi to your fans.
Hey everybody, how you doing? I'm Jason Puma. I'm a senior Met here at Indianapolis, and today we're just doing a little Periscope exercise just to talk a little bit about the possible severe weather threat today across mainly southern central Indiana. And we also want to let you know that we're actually using this Periscope as sort of a test project. We're trying to see how we can integrate it into our operations to help get out our information, because that's what we're all about at the Weather Service, is protection of lives, protection of property, and getting our information out to people so folks can make real good choices as to how to stay safe from storms and keep their families safe, etc., stuff like that. So, that being said, we're going to cover a couple things today. We're going to talk a little bit about severe weather, this is a severe weather threat, like I mentioned, and we're also going to talk about, I also want to go over some questions with you. If you might have any questions out there, anything that's on your mind, now's the time. Go ahead and type it in there, and we'll try to answer them the best we can. So.
All right, and I'm Earl Breon. I'm the observations program leader here, and I'm going to be kind of guiding Jason through this. So the way we're going to work the questions is he's going to go through a couple of topics. If your question jives in with that topic, I'll go ahead and interrupt him. We'll try to get it answered. And if not, we'll save it for a general Q&A session at the end. So I'm going to spin it back around here to Jason, and he's going to hit the ground running for you guys.
Okay. Let's first take a look at if you haven't seen the Storm Prediction Center, they've put the southern part of our forecast area into an enhanced risk. There's a slight risk across the far south, and part of that, within that slight risk, is an enhanced risk. So let me show you a little map here. If you can go to a website, if you don't know about the Storm Prediction website, it's www.spc.noaa.gov. So, here's the state of Indiana right here, and you can see this yellow area right here, mainly along and south of Interstate 70, estimated, is in a slight risk for severe thunderstorms, mainly this afternoon. And beneath that area, there's an area of orange. Now that is enhanced risk. Now what does that mean? What does slight risk and enhanced risk mean? What are we talking about? What's the SPC talking about? Well, slight risk means scattered severe storms are possible. Generally, that means might expect the weather services here and in Louisville, which cover this area, could be issuing some severe thunderstorm warnings later, or there could be a watch later. The storms essentially with this event would be short-lived, not really widespread, but more of an isolated scale. Intense storms would be possible. You could have 1 or 2 tornadoes possible, and you generally like severe hail around 1 inch. So kind of your typical severe thunderstorm stuff. Stronger than your average thunderstorm, so to speak. A storm that would produce damage, and we'd have severe thunderstorm watches out or warnings, etc. So what's the difference between a slight risk and an enhanced? Well, enhanced is sort of just a notch up from slight. All right. Instead of just scattered storms possible, enhanced means numerous severe storms are possible. The storms are more persistent, they're more widespread, and they could be even a little bit stronger. When you have an enhanced risk, not just 1 or 2 tornadoes are possible. The tornado risk is slightly higher, and we're also expecting more damage, better chances of wind damage in that area, and stronger updrafts as well that could produce even larger hail than, say, 1 inch or 2. So enhanced just means, hey, the risk is a little bit more significant. It's not quite to the moderate or the high levels where you were expecting a large, widespread outbreak. We're not in that situation at all today. But it's a little bit better than your average slight garden variety severe thunderstorm watch day. So going back to the watch area, let's take a look. Or excuse me, this is what it's not the watch area, it's the convective outlook from the Storm Prediction Center. And they have the enhanced area down here across generally the Ohio Valley, across far southern Indiana, and much of the bluegrass across Kentucky as well. and the slight generally along and south of I-70. So this is an area that we'll probably watch, because I wouldn't be surprised if we had to have a severe thunderstorm watch perhaps later on this afternoon or into the evening hours as well. So why are we forecasting that? What's all the meteorology behind this? When's it going to happen? You got questions?
Yeah, well, just segue into what you're getting ready to get into. We've had a question about what are CAPE values for the day, and then specifically severe weather potential in Brazil, Indiana. And then as you're transitioning to that, we had a question about torcons. Torcons really aren't our thing, so we're not going to be able to answer that one for you.
Okay, well, I'm glad you asked about CAPE. Let's first talk about, I'm going to get to the CAPE and stuff. We'll look at some forecast soundings across the area as well. But let's take a look at AWIPS over here. This is our computer system showing what's going on right now. I'm going to show you this first off right here.
Let me get this.
Let's get in there real close.
While we're maneuvering this, do us a favor, feel free to share this so we can get more eyes on it. We really appreciate it.
So what's going on today is this is water vapor imagery. So this is satellite imagery that is showing the amount of water vapor available in the mid and upper levels parts of the atmosphere. On a day like today, it's really useful to determine where we can find upper level disturbances, and these are things that help to cause lift and help generate thunderstorms. So today you can see here's Indiana, and in this image the bright orange and yellows, that indicates dry air, and the grays and the purples and the blues, that's moist air. And if you look at this flow, this is the flow aloft, you can see a little swirl here moving across Illinois and into Missouri and into Illinois. And you can see a little wave right here as well that's moved across central Indiana. Now what we're looking at here is this is this first little wave of rain that sort of is pushing north across central Indiana late this morning, and that's exiting the area now. But the second part of the system down here across southern Illinois, this is the part of that short wave that is going to essentially be our producer for severe thunderstorms potential later on this afternoon and into the evening hours. So within this flow, we can sort of, I've overlaid a model flow of the upper flow, and you can sort of see the flow is initially ridgy across the central portion of the of the Plain States, and then we get into this feature, this trough-like feature across the mid-Mississippi Valley as the flow sort of comes up, down, and up, loops around. Now this trough here, this is what we call a negatively tilted trough. So a trough like this is ideal for producing precipitation, producing lift. It's an ideal setup, and sometimes you can, especially this time of year, a little bit of an enhanced feature as far as for a severe weather setup. So this is another reason why the Storm Prediction Center has an enhanced risk. It produces winds in different directions, ideal for tornado setup. So that's the setup aloft. Looking at radar right now, you can see here's our first wave exiting central Indiana right here. And here's our next wave down here. This is across western Kentucky, across Paducah's area, and moving into Lincoln's area, across the southern parts of their forecast area, and exiting the St. Louis area. So there's a few thunderstorms down here moving across western Kentucky right now in southern Illinois. And this is what we're going to watch as it moves into the enhanced risk area later on this afternoon, mainly across Louisville's area and the Ohio Valley and southern Indiana. Now, looking at the clouds across that area, you can see there's a few breaks in the clouds right now across that area. You can see right here, this is the visible satellite. You can see these dark spots here, that's essentially sunshine that's moving into the area. And what that's going to do for us, that's certainly going to allow temperatures to rise. We'll heat things up, we'll destabilize things ahead of that system, giving these storms as it advances into southern Indiana and central Kentucky more fuel to help generate and possibly become severe. So those are two things that we're looking for. Let's look over here at somebody was asking about the CAPE values. Now over here I have what's called a forecast sounding. And this is just a model guess. A guess of what a computer model thinks the atmosphere is going to be like at a certain time. So this model in particular, let's jump to this afternoon around 2 p.m. at Indianapolis. And this is what our forecast sounding looks like. and it's giving us CAPE values of over 2,000 joules per kilogram. So that's pretty good. If you're not familiar with CAPE, those that are familiar with CAPE, that's ideal for thunderstorm development, providing lots of juice aloft. Now again, this is Indianapolis. A little bit further south, these values might be a little bit higher as well. But nonetheless, 2,200 joules per kilogram, that's pretty good as far as CAPE. You can see the CAPE area in the sounding is essentially the area between this red line here and this dotted white line. So that's plenty of potential upward motion available as parcels are heated and becoming more unstable. So that's all the reasoning. So we'll look for essentially the heating ahead of that short wave like I showed you on the satellite image. And as that wave moves in, that's going to provide lift. We have moisture, we have heating, we have instability, we have a triggering mechanism. So we have lots of things coming together that help produce thunderstorms. And some of them, like the Storm Prediction Center has said, possibly could get to the severe side. And when that becomes a little bit more evident, the timing on this thing would probably be late this afternoon and into the evening hour. Actually, before I summarize, let me show you one last model. I should have showed you this before. And this is the rapid refresh model. And it does a pretty good job with convection, sort of indicates what it thinks, how thunderstorms are going to develop and how they're going to move across an area. So this is right now, and it sort of is handling our first wave across central Indiana here, and here's our next wave down here as well. And as time goes on each hour, you can see that it continues to develop. Let's change the view just a little bit. It develops these showers across southern Illinois and western Kentucky, showers and storms moving a little bit like a bow echo, it's suggesting, across the southern parts of central Indiana. So we'll have to see if this comes to fruition. Again, this is just a model guess. It's not actually what's happening right now, but this is what the model thinks might happen. And based on what we're seeing in the satellite imagery, it seems like that's really pretty reasonable to think that as we have all these ingredients coming together to do this sort of thing. So, and then by 22Z, which is about 10 p.m., it moves all those showers and storms out of the area. So, our main time frame for showers and storms this afternoon, again, say from 4 p.m. to 8, 9 p.m. Possible we could have a watch, especially across the southern parts of the area. We'll have to stay tuned and see what the SPC decides to do with that, and go from there. We got some questions, Earl, before we wrap things up?
We had a couple questions that came in that you mostly answered. Someone asked about how the sunshine right now would help fuel storms later on. So I think you answered that. If you could chime back in, did he answer your question for you?
Yeah, if there's that's the main key here when we look at our imagery over here with the visible imagery. As we get this sunshine out here, that's certainly going to allow some heating and some instability to develop. Allow those temperatures to rise up towards our convective temperatures of mid-70s or so, lower 70s. We also notice we have southerly winds across Kentucky and across southern Indiana. Those southerly winds are bringing warmer temperatures up along with that sun heating. So that, again, that's all providing more juice, more fuel to help get these storms going over the course of the day. So we'll see what happens with that. So I hope that answered your question.
I believe so. I haven't seen them chime back in. We just had I guess, kind of a question statement. Is there enough instability, lift, shear to get severe thunderstorms going?
Well, it's possible, and that's why we have it's possible that we have enough ingredients in place to get severe thunderstorm excuse me. It's possible that we have enough ingredients together to get severe thunderstorms going, and that's why we have the slight risk in place, or Storm Prediction Center does, and the enhanced risk across the far south. So yes, it's certainly possible. We went over all those ingredients of why it's possible. The southerly flow, the heating, the instability, the CAPE, everything that's there, and the shortwave moving into the area. Those are all those sort of key classic ingredients that you need to get thunderstorms going.
All right, so let's go ahead and get some more questions coming in here for Jason. I saw a lot of spotters in the names when he popped in. Just want to take a quick second to say thanks to all of our spotters. We really appreciate you. When times like this hit, that's when we really rely on you guys to give us some ground truth type evidence. So you got some more questions, get them in right now, and I'm going to spin this back around to Jason so he's ready to go when they come in.
So we got any more questions coming in today?
We did get a thanks, guys, for doing this. I guess while we're waiting for some more questions, well, let's ask the question for this experiment. How do you guys like us using Periscope like this, and do you have any other ideas on what you would like to see us do through Periscope?
That's a good question. And while they think about that, I thought of something else we could show them real quick.
Oh, really?
And yeah, and that
Beauty of live TV.
is we could talk a little bit about how we issue warnings, or one thing that goes into making decisions of making a warning, and something that we'll be looking at today. One thing that we look for is cores of updrafts, all right, and how strong those updrafts are off. And often what we look for is the 50 dBz level. So that's a level within a radar image of how strong it is and how high it is. The higher that cell is, the higher that higher level dBz level is, that lets us know potentially whether a storm has hail or whether it doesn't have hail. So based off some of the models and what we're seeing out there, we've come up with some numbers based upon studies primarily done out of the Des Moines office. They've done this, and we've used this technique for numerous years to develop when we can get, when we're going to start seeing large hail fall out of storms. So our numbers are over on our board. Let's go look at our board, Earl. Let's go check that out.
Okay. Bring this over here. Let's see here. Got a question about, do you have any idea on timing when the cap will break?
Okay, I'll answer that question in just a second. So these are our numbers. We posted them this morning on the board. Today the freezing level is around 10,300, actually 10,400 feet. So you get above that level in the sky today, that's temperatures are below zero, so that's where your hail is going to start forming. In order to get 1 inch hail, that's our severe criteria, 1 inch. We need to have on radar, we need to see a cell, we need to see a 50 dBz cell of up over 25,274 feet. That's according to our science and study. So once we see values up that high, that's when you can probably suggest us issuing warnings. Those are some of the things as far as hail is concerned, we'll issue warnings. Now we just don't issue this on this stuff alone. We're also looking at velocity information as far as winds and et cetera like that. And this number here, this would be the number we would expect for 1.75 inch hail. That's golf ball size hail. You'd need an updraft lifting a 50 dBz return to 30,000, nearly 31,000 feet. So that would be pretty tall today. It's certainly possible. Can't rule it out, but it's something that we're aware of and we're looking for along those lines. So now we had a question about when the cap is going to break. Mm-hmm. Well, probably, like we mentioned, we'll be watching for once we start hitting those convective temperatures around in the mid-70s, that we'll start seeing tall thunderstorms developing mainly across the southern parts of the forecast area. So I would guess that once we get into the lower 70s and those mid-70s, we'll start seeing that sort of thing happening.
Okay. And then we had somebody who was a late joiner. If you could just real quick kind of recap the threat. They say they're looking to go spot for us down south.
Oh, okay. Well, let's go back to the workstation, and we can wrap this up.
So, as Jason was saying, we're going to need to try to wrap this up here in the next few minutes. So if you do have any final questions, get them in now. I want to say thanks for all the comments about Periscope and how you enjoy it. We'll go back and pull those off. And it's going to help this project likely become more permanent than experimental as it is now. So thanks for the comments. Get the questions in. We're probably wrapping up here in the next few minutes. This is your chance. And again, share it. You'll be able to watch it later with the folks that you share it to. So, Jason, down south.
So, wrapping this up summary-wise, someone was asking where the threat's going to be, and really, again, the threat, southern Indiana. The northern part of the Louisville forecast area, the southern part of Indianapolis's area. Generally, the slight risk is contained essentially along I-70 and southward. So, and the timing on this would probably start looking for some storms to develop, say, around 20Z, which is about 4 p.m. Eastern Time, and running through the late afternoon and into the evening hours. And that's what our models continue to suggest, like we showed you on the rapid refresh model. And like as we saw as far as the, oh, I'm sorry, I lost my train of thought. But as far as the rapid refresh model, and also as due to the daytime heating, that's when the best instability will be in place as temperatures reach those convective temperatures and unleash that cape available aloft. So, spotters, we'll be looking for your reports if you do it. So you can always follow us on, we always try to post our tweets to hashtag INWX. You can also tweet us directly at NWS Indianapolis. You can visit us on our Facebook page. Look for U.S. National Weather Service Indianapolis or NWS Indianapolis on Facebook. You can visit our webpage at www.weather.gov/IND. If you're on the phone, you're on your cell phone, you want to find out weather information, look at mobile.weather.gov. So there's lots of ways to interact with us and send messages to us and get information from us, because that's what we're all about. We're trying to get the information out to you and make sure that folks can make good decisions, stay safe out there, and get that warning information when weather does become threatening. So I think that's about it. We're going to wrap this up. Maybe if things do develop and we have the staffing available, we'll try to do some updates as the storms are moving, but those would be much shorter, much briefer than what we're talking about this. It depends upon our staffing as we sort of learn about Periscope. So thanks for joining in with us today. Thanks for tuning into our broadcast. We hope you liked it, and we'll see you next time. Stay safe.
All right, and Jason's going to get back to looking at that forecast for you. We're going to close out here. You guys are welcome. Just remember, once we get done with these, we're going to post them on our Facebook, YouTube channel. If you're not on our YouTube channel, we've got a lot of great videos on there on how to get to some of our services and products. We're going to see these out over Facebook, Twitter, and if you haven't yet, follow us directly on Periscope, and thank you for your time.